Parkinson's disease is the second most common neurodegenerative disease worldwide after Alzheimer's. It affects over 153,000 people in the UK alone, with over 10 million individuals worldwide battling its debilitating symptoms. Yet, despite its prevalence, Parkinson's remains without a cure. Here at the Kavli Institute, Oxford, dedicated research groups spanning various departments are leveraging their expertise, cutting-edge instruments, and innovative approaches in a united effort to unlock the mysteries of Parkinson's and develop effective treatments for those living with the disease.
Standing up in front of a group, doing presentations, I was doing them all the time. And now I find that even just simple conversation, I struggle over certain words or terms or whatever, and there's no logic to it.
My own lab works on the genetic forms of Parkinson's using a key technology called induced pluripotent stem cells. In this work, what we're able to do is to take a small skin biopsy from a Parkinson's patient, turn that skin cell sample into stem cells. Once you've got stem cells, you can generate any cell type you like. So here in my laboratory, we're turning these stem cells into dopamine neurons, and then we can study the biology of these neurons in the dish in the lab. Once we have specific disease mechanisms, we can develop new targets and new therapies.
Parkinson's disease is due to the loss of dopamine neurons in the brain. A protein called alpha-synuclein aggregates in these neurons, causing a toxic effect and their loss, causing neurodegeneration.
We try to work out how it is that the protein aggregates to form the various structures that cause the disease, and also specifically how other molecules act to stop that happening inside the cell. Particularly, there's a protein called glucocerebrosidase. Mutations in this protein are the biggest risk factor for Parkinson's disease, and we found that these specific mutations have very strong effects on the way alpha-synuclein aggregates.
We also need the new approaches in the clinic to identify early forms of Parkinson's, so identify individuals who are at risk of Parkinson's or developing very early stages of the condition, because then basically you've got lots of neurons there to protect, and that's when neuroprotective therapies will become most effective.
Although patients with Parkinson's present with a familiar movement disorder and dementia, the pathology actually starts more than 10 years before people come to our clinic. This is because brain cells fail to handle a small protein called alpha-synuclein, which accumulates in the nerve cells and damages vulnerable neurons.
In their recent paper, the Tafaris group discovered that it is possible to detect the risk of Parkinson's disease 7 years before the physical symptoms occur. While this advancement doesn't currently aid in treatment, it offers hope for earlier intervention and management strategies, marking a significant stride forward in Parkinson's research.